Our daily lives are filled with decisions. You meet a new colleague and wonder whether they're trustworthy. You see a sensational claim on social media and want to share it, but you're afraid it might be false. You feel slightly unwell and try to decide whether it's worth going to the hospital. In each case, you need to make a judgment. And naturally, you want that judgment to be correct. But if you followed the ideas we've discussed so far, you've probably realized something important. Every decision contains a degree of subjectivity. Choosing what you value, selecting a model of reality, deciding what level of detail matters. These are all subjective choices. There is no perfectly objective viewpoint. Every action involves some uncertainty and some risk. If you accept that, you might already be a Bayesian. Today's thinking tool is Bayesianism, and we'll focus on one of its most important concepts: the prior. A prior is your existing belief about something before receiving new evidence. It could be your estimate of the probability of a specific event, your view of an entire field, or even your overall worldview. Put simply, a prior is your prejudice. But prejudice is not necessarily a bad thing. It is the starting point of cognition. And unlike blind bias, a Bayesian prior can be quantified, updated, and examined. Ordinary people might say, "What's your opinion on this?" or "That experience changed my view." A Bayesian would say, "What's your prior?" or "That evidence updated my prior." This way of speaking comes from the famous Bayes theorem. You don't need to memorize the formula. The essence is simple. Your current belief equals your previous belief adjusted by new evidence. Or in even simpler terms, posterior belief equals prior belief plus evidence update. Let's look at the classic example. Imagine a rare disease that affects only 0.1% of the population. Before any testing, the probability that your friend has the disease is therefore 0.1%. That's your prior. Now suppose there's a medical test that's 99% accurate. If someone has the disease, the test returns positive 99% of the time. If they don't have it, the false positive rate is only 1%. Your friend takes the test and receives a positive result. Most people immediately think, well, the test is 99% accurate, so he almost certainly has the disease. Not so fast. Imagine testing 1,000 people. Based on the disease rate, only one person actually has the disease. That person will likely test positive. But among the 999 healthy people, about 1% will also test positive by mistake. That's roughly 10 false positives. So now we have about 11 positive test results in total, but only one of them belongs to someone who actually has the disease. That means the probability that your friend truly has the disease, given a positive test result, is only about 1 in 11. That's much higher than the original 0.1%, but it's still surprisingly low. Why? Because the disease was extremely rare to begin with. The prior mattered. Even strong evidence cannot completely overcome an extremely unlikely starting point. This is part of the Bayesian mindset. Suppose I believe that world-class soccer prodigies are incredibly rare. You can tell me about a child on a local team who looks amazing. You can tell me coaches think he's the next Lionel Messi. Those stories may raise my estimate, but they won't instantly convince me. Likewise, if I strongly doubt the existence of ghosts, hearing 15 ghost stories won't suddenly make me afraid of haunted houses. Evidence updates beliefs, but it starts from somewhere. And today's posterior becomes tomorrow's prior. The deeper philosophical question is, what exactly is probability? When you say something has a 50% chance of happening, are you describing reality itself, or are you describing your confidence about reality? Traditional probability theory, often called frequentism, treats probability as an objective property of the world. A fair coin has a 50% probability of landing heads. That's considered a true value. If you flip it enough times, the observed frequency should converge to that value. Bayesians see things differently. They point out that most important events in life don't happen thousands of times. Will this candidate win the election? Will this startup succeed? Will this relationship last? You don't get to replay life 10,000 times and calculate frequencies. Many important decisions involve unique events. So Bayesianism defines probability as a degree of belief. Probability exists in your mind. It measures uncertainty. Frequentists tend to view themselves as observers of the world. Bayesians view themselves as participants in the world. Every probability is conditional. Every action gathers evidence. Every new piece of information updates beliefs. Different people have different experiences and therefore different priors. In that sense, Bayesian probability is inherently subjective. At this point, you might object. If probabilities are subjective, doesn't that make them unreliable? After all, people can invent any prior they want. That's true. Which is why a good Bayesian doesn't pull priors out of thin air. The best starting point is often the known frequency of events, the scientific consensus, or the collective knowledge of society. In the disease example, if we know nothing about a person, using the population disease rate as our prior is reasonable. But suppose we learn more. Maybe the person is young. Maybe they're unusually healthy. Maybe they have specific symptoms. Each piece of information becomes evidence that updates the prior. In this way, general statistics become personalized predictions. This idea turns out to be incredibly useful. Consider spam email filtering. Suppose 20% of all emails are spam. You can't simply label 20% of incoming emails as spam at random. Instead, you examine evidence. Words like free, winner, or limited offer might appear more often in spam emails. Words like meeting, project, or schedule might appear more often in legitimate emails. Each word becomes a piece of evidence. Start with a prior probability of 20%. Every time you encounter a word, update the probability. Free nudges the estimate upward. Meeting nudges it downward. By the time you've processed the entire email, you have a posterior probability that the email is spam. The system isn't guessing. It's keeping a probability ledger. In many ways, modern large language models operate similarly. Training embeds vast prior knowledge into model parameters. Prompts provide new evidence. The model updates its probability distribution and generates a response. AI companies also try to build strong priors that cannot easily be overturned by prompts. This is what we call alignment. Of course, users constantly attempt to override those priors through jailbreaks. Seen from this perspective, aren't we all walking language models? Our experiences, education, and upbringing form our training data. They become our priors. This connects beautifully to the free energy principle. According to this view, the brain is fundamentally a prediction machine. Your expectations are priors. Your surprises are evidence. Imagine reaching for a cup of water. Before you touch it, your brain already predicts where it is, how heavy it is, and how it should feel. Those predictions are your priors. When your fingers make contact, reality provides feedback. If the cup is much hotter than expected, you experience surprise. Now you must update your model and adjust your behavior. Perhaps pulling your hand away. The sequence is always the same. Predict. Receive feedback. Update. We never begin with a blank slate. Even an imperfect map is better than no map at all. And when reality conflicts with your expectations, you must respond somehow. You can update your beliefs. Or you can change the environment itself. If you expect a warm room but discover it's cold, you can revise your expectations. Or simply turn up the heat. Either way, doing nothing is not an option. As the economist John Maynard Keynes famously said, "When the facts change, I change my mind." What do you do, sir? Unfortunately, people often make two mistakes. The first mistake is having no prior at all. Some people think being completely neutral is scientific. But that's impossible. You shouldn't assign equal probability to the sun will rise tomorrow and the sun will explode tomorrow. Without priors, every new headline completely reshapes your beliefs. Today you believe one story. Tomorrow you believe its opposite. You become endlessly reactive. That's not open-mindedness. That's unpredictability. The second mistake is treating priors as untouchable truths. In Bayesian terms, this means assigning a probability of exactly 0 or exactly 1. If you do that, no amount of evidence can change your mind. Bayesians strongly advise against this. It's known as Cromwell's rule. The name comes from Oliver Cromwell, who once wrote, "I beseech you, think it possible that you may be mistaken. Always leave room for the possibility that you're wrong. Even if you're 99.999% certain about something, don't make it 100%. The practical lesson of Bayesianism is surprisingly simple. Start with a reasonable prior based on the environment. Then treat specific experiences as evidence that updates it. Suppose you're trying to decide whether a new colleague is trustworthy. Begin by considering the broader context. If you're in a highly competitive environment where people often act opportunistically, start with a lower prior. If you're part of a healthy, cooperative community, start higher. But that's only the beginning. You still need evidence. Work with the person. Observe their actions. Let reality update your estimate. Many traditional sayings that appear contradictory suddenly make sense through this lens. Trust people. Be cautious. People can change. Appearances can deceive. All of these are simply statements about priors and evidence. Our priors are both our greatest asset and our greatest prison. Evidence is not a collection of absolute truths. It is the currency with which we trade for better beliefs. Every experience is an opportunity to purchase a more accurate understanding of reality. And if this discussion has updated even one of your priors about how the world works, then it has achieved its purpose. That's it for today's content. Thank you for watching, and I'll see you in the next video.